Right now, at this very moment, as you listen to these words, the most powerful solar flare of 2025 is slamming into Earth's magnetosphere. Not yesterday, not last week, but today, November the 12th, 2025. A geomagnetic storm so intense that auroras are dancing across skies as far south as Alabama, painting the night in colours that most people in those latitudes have never seen in their lifetimes. This is a major space weather event, a direct consequence of our star's violent and unpredictable nature. But here is what nobody is talking about. Here is the detail that should make every single person pause and really think about what is happening above our heads right now. The interstellar visitor, 3I Atlas, which just passed through the most intense heat and radiation of its entire journey through our solar system, emerged from its hiding place behind the sun exactly as this storm began to build. The timing is so precise, so statistically improbable, that it demands we ask a question that most scientists are afraid to even whisper. What if these two extraordinary events, the most powerful solar storm of the year and the re-emergence of a bizarre interstellar object, are not a coincidence? What if they are connected in a way we're only just beginning to comprehend? Before we go any further, I need you to do something for me. If you are finding value in this deep dive into what might be the most significant cosmic coincidence of our generation, or perhaps something far more deliberate, hit that like button and subscribe to the channel. We are building a community of people who refuse to accept surface-level explanations, who want to dig into the data and see what is really happening in our solar system. And tell me in the comments, where are you listening from? What time is it there right now? And are you able to see any auroras tonight? I want to know if this storm is reaching your part of the world, because what is happening in our atmosphere is only the beginning of a story that stretches across our solar system and perhaps far beyond. The story begins yesterday morning, November 11th, 2025. The time is 10:04 Universal Time. On the surface of our Sun, in a region of tangled magnetic fields designated AR4274, something extraordinary happens. A solar flare erupts with such violence, such raw, untamed power, that it instantly becomes the strongest solar eruption we have witnessed all year. The classification comes back from space weather agencies as an X5.1. To put that in perspective for you, X-class flares are already the most intense category we have. They are the heavyweight champions of solar activity, capable of releasing energy equivalent to billions of hydrogen bombs detonating all at once. But this one, this particular beast, ranks at 5.1 on that already extreme scale. It is not just strong, it is overwhelming, a true monster of a solar event. The flare itself is a flash of almost unimaginable brilliance, electromagnetic radiation, a wave of X-rays and extreme ultraviolet light, screams away from the sun at the speed of light, crossing the 93 million miles to Earth in just over 8 minutes. When that wave of radiation hits our upper atmosphere, the effects are immediate and severe. Radio communications across Africa and Europe, the entire sun-facing side of our planet, simply stop working. High-frequency signals that pilots, emergency services, and maritime vessels depend on are gone in an instant, absorbed by an ionosphere suddenly supercharged with energy. The technical term for this is an R3 level radio blackout, which sounds clinical and sterile until you realize that means a severe disruption to a continent's worth of critical communication infrastructure. It's a reminder that we live within the extended atmosphere of a volatile star, and that star can reach out and touch us at any moment. But that initial blast of radiation, as disruptive as it is just the opening act. The real show, the part of the event that is hammering our planet's magnetic shield right now, came from what happened next. Sunspot AR4274 did not just release energy in the form of light, it ejected mass. Billions upon billions of tons of plasma, a superheated gas of protons and electrons, along with a tangled knot of magnetic field, were ripped away from the solar corona and began racing toward Earth. This cloud of solar material is called a coronal mass ejection, or CME, and it represents the true physical threat from a solar flare. It is a tsunami of magnetized plasma hurtling through interplanetary space. And this was not the only one heading our way. In the days leading up to this monster eruption, the same angry, unstable region of the sun had already fired off 2 other major flares, setting the stage for what was to come. On November 9th, it produced an X1.7 flare, a major event in its own right. Then, on November 10th, it followed up with an X1.2 flare. Each one of these eruptions launched its own cloud of solar material, its own CME, on a trajectory that would intersect with Earth's orbit. We had 3 separate storm clouds racing toward us, a solar onslaught building in intensity with each passing day. Now, here is where the physics gets fascinating and deeply concerning. When multiple CMEs are launched in quick succession along similar paths, something remarkable and dangerous can happen. The faster one, the one from the powerful X5.1 flare, catches up to the slower clouds that were launched ahead of it. They don't just pass through each other. They merge, they combine, they coalesce into what solar physicists call a Cannibal CME. Think of it like a storm front on Earth, overtaking and absorbing the smaller weather systems ahead of it, growing more powerful and more complex with each merger. The magnetic fields of the individual CMEs intertwine and amplify, creating a structure that is far more potent than the sum of its parts. The particle density increases, making the cloud a more formidable battering ram. What arrives at Earth is not 3 separate manageable impacts, but one single, massive, combined assault on our magnetosphere. The predictions from space weather agencies started coming in fast. The Space Weather Prediction Center, part of NOAA in the United States, issued a geomagnetic storm watch. Not a minor watch, not a routine alert, but a G4 warning. That stands for severe geomagnetic storm conditions, the second highest level on their 5-point scale. They projected the impact would occur around midday on November 12th. They were right. The Cannibal CME began hitting our magnetosphere just a few hours ago, and the storm is building to its peak right now as you listen to this. The official alerts also carry a chilling possibility for the near future. The conditions could escalate even further, potentially reaching G5, or extreme, if the densest, most magnetically potent part of the CME is still incoming. We may not have seen the worst of it yet. But let me tell you what makes this moment in time so statistically strange, so cosmically suspicious, that it deserves much more attention than it is getting. 3I Atlas, our enigmatic interstellar guest, reached perihelion, its closest approach to the Sun, on October 29, 2025. For those keeping track, that is exactly 2 weeks ago, 14 days. The object spent that entire time hidden from Earth-based observation, tucked away behind the Sun in what astronomers call solar conjunction. We could not see it. Our most powerful telescopes, our most sensitive instruments, all pointed uselessly at a region of space completely washed out by the Sun's overwhelming glare. We were blind to whatever was happening to it during the most critical phase of its journey. During those 2 hidden weeks, 3I Atlas was exposed to an environment of almost unimaginable hostility. The solar irradiance it experienced was roughly 770 watts per square meter. To put that in human terms, imagine standing in the most intense desert heat you have ever experienced. Then multiply that by factors that make the comparison almost meaningless. For an object that spans somewhere between 5 and 20 kilometers in diameter, depending on whose measurements you trust, that translates to more than 33 gigawatts of power being delivered continuously to its surface. That is not a typo. 33 gigawatts, a third of the entire nuclear power generation capacity of the United States, focused on a single object hurtling through the inner solar system. And now, just as it emerges back into observable space, just as it comes back into view for astronomers around the world, the Sun erupts with its most powerful flare of the year and sends a Cannibal CME racing directly toward Earth. The timing makes you pause, it makes you wonder, it makes you ask questions that sound crazy until you really think about them. Let me walk you through what we know happened to 3I Atlas during its perihelion passage, because the details matter here. They matter a lot. On November 5th, just 1 week after its closest approach to the Sun, 2 observatories released the first post-perihelion images of the object. The Arnaves Observatory in Spain and the Virtual Telescope Project both managed to capture 3I Atlas as it finally emerged from behind the Sun's glare. Scientists and amateur astronomers around the world eagerly pulled up these images, expecting to see exactly what you would predict from a comet that just survived a close solar passage. They expected to see a massive tail, a brilliant cloud of dust and gas, clear and undeniable evidence of the intense heating and outgassing that should have occurred as its ices were vaporized by the Sun's heat. What they saw instead was deeply strange and profoundly confusing. The images showed a compact source of light, a fuzzy ball, with no clear cometary tail pointing away from the sun. There was no obvious debris field, no spectacular display of ejected material. The morphology, the basic shape and structure of the object, looked remarkably similar to images taken by the Hubble Space Telescope way back in July, before the perihelion passage, when it was much farther from the sun. It was as if 3i Atlas had gone through the most intense thermal and radiation environment of its entire journey and had come out the other side looking almost completely unchanged. Now let me explain why this is so weird from a physics perspective. NASA's Jet Propulsion Laboratory, or JPL, had detected what they call non-gravitational acceleration in the trajectory of 3i Atlas. This means the object is not moving purely under the influence of gravity from the sun and planets. Something else is pushing it. For a natural comet, that something else is outgassing. Ice on the surface heats up, turns directly from a solid into a gas in a process called sublimation, and jets of vapor shoot out like tiny natural rocket engines. The momentum from those jets pushes the comet slightly off its predicted gravitational path. Harvard astrophysicist Avi Loeb, a prominent and often controversial voice in this field, did the math on this. Based on the precise amount of non-gravitational acceleration measured by JPL, he calculated that 3i Atlas must have lost more than 13% of its total mass during its pass around the Sun. 13%! That is a massive amount of material. For a comet with a diameter of 5 to 20 kilometers, we are talking about an enormous quantity of matter being ejected into space. Hundreds of billions, perhaps trillions, of tons of ice and dust. When a comet loses that much mass, when that much ice sublimates and that much dust gets blown off by the pressure of solar radiation, you get a tail. You get a big, obvious, unmistakable cometary tail stretching for millions of kilometers away from the Sun. But 3i Atlas did not have one. The November 5th images are clear on this point. There is a coma, yes, a fuzzy envelope of gas and dust immediately surrounding the nucleus, but there is no significant tail. This is the first major paradox. The object's trajectory tells us it must have lost a huge amount of mass, but the images tell us that the expected result of that mass loss, a spectacular tail, is mysteriously absent. Then, on November 8th, things got even stranger. A team of skilled observers, including M. Jagger, G. Riemann, and I. Prosper, captured 3i Atlas when it was at a 29-degree separation from the Sun. They stacked multiple long exposure images taken through different color filters to build up a detailed composite picture. What they found was truly remarkable. There were at least 7 distinct jets of material emanating from the nucleus of 3i Atlas. Not a single, diffuse tail pointing away from the Sun, but 7 separate, well-defined streams. Some of these jets were pointing in an anti-sunward direction, as you might expect. But incredibly, some of them were pointing anti-sunward, which is a confusing term for pointing directly toward the Sun. This violates everything we expect from the known physics of solar radiation pressure and the solar wind, which should always push material away from the Sun. These jets reached out to a distance of roughly 500,000 kilometers from the nucleus. Think about what that means for a moment. If 3i Atlas is a natural comet and it is producing 7 distinct jets in multiple directions, including physically impossible sunward jets, then the amount of mass being ejected must be absolutely enormous to create that kind of structure. The mass loss would have to be far more than 10 or 20%, possibly more than half of the object's original mass. And yet, the images do not show a massive chaotic debris cloud. They do not show the kind of diffuse, extensive coma you would expect from an object that just shed half its own body weight. The structure is organized, almost geometric, in a way that defies simple natural explanations. On November 9th, more images came in, this time from dedicated amateur astronomers Michael Yeager and Frank Neuling, who are part of the British Astronomical Association. They used 2 different telescopes to create composite images that revealed even more detail. They confirmed not just a long tail but also 2 distinct anti-tail jets, features that should simply not exist on a normal comet following normal physics. So, here we are. 3i Atlas passes through perihelion, loses a substantial fraction of its mass according to trajectory measurements, displays multiple jets, including physically impossible sunward jets, and yet emerges without the massive, glorious tail you would expect. And during this exact same time window, while 3i Atlas is hidden behind the Sun, undergoing these bizarre changes, the Sun itself builds toward the most powerful eruption of the year. The Cannibal CME that is hitting us right now originated from a sunspot that was not particularly special 2 weeks ago. AR4274 showed activity, sure, but nothing that screamed imminent record-breaking flare. Then, in the span of just 3 days, from November 9th through November 11th, it produced 3 X-class flares in rapid succession. The last one, the X5.1, came exactly as 3i Atlas was emerging back into our observable sky. Solar physicists will tell you that the Sun is in solar maximum, the predictable peak of its 11-year activity cycle. Flares happen, CMEs happen. Clusters of activity from a single active region, that happens too. They will tell you that all of this is normal solar behaviour. They will say that the timing with 3i Atlas is just a coincidence, a meaningless correlation. But is it? When you are dealing with an interstellar object that has already displayed at least 8 statistical anomalies in its trajectory, its composition, and its behaviour, when that object passes through the most energetically intense moment of its journey exactly as the Sun produces its strongest flare of the year, at what point does coincidence become an insufficient explanation? At what point do we have to start considering that something else, something far more profound, might be happening? The geomagnetic storm hitting us right now is already being measured at G4 levels. Severe storm conditions. Auroras are visible across a latitude range we rarely see. Power grids are experiencing voltage irregularities. Satellites are reporting orientation issues from the intense bombardment of charged particles. High-frequency radio is degraded across the entire planet. This is a serious space weather event, a real test of our technological resilience, and if the strongest part of the CME is still on its way, we could see conditions escalate to G5, extreme, the highest level on the scale. Meanwhile, 3i Atlas continues its journey. It is now moving away from the Sun, heading outbound through the solar system. In early December, it will pass within 97 million kilometers of Venus. On December 19th, it reaches its closest approach to Earth at a distance of roughly 267 million kilometers. That is far enough to be safe from any direct physical impact, but it is close enough for our best telescopes to finally get a really good look at whatever this thing actually is. The question that hangs in the air, the question that connects today's geomagnetic storm to the bizarre perihelion passage of 3i Atlas, is simple to ask but terrifying to really consider. What if the timing is not a coincidence? What if there is a connection we do not yet understand between an interstellar visitor and the sudden, violent activity of our own Sun? What if this perfect storm was not an accident of nature, but a deliberate act of celestial engineering? What if the timing isn't a coincidence? There is a concept in physics that most people never encounter unless they study orbital mechanics or work in aerospace engineering. It is called the Oberth effect. Named after Hermann Oberth, one of the founding fathers of rocketry, it describes something beautifully counterintuitive about how velocity and gravitational potential energy interact. The basic principle is this: if you want to change your trajectory in space as efficiently as possible, you do it when you are moving your fastest, and you move your fastest when you are closest to a massive object, at the point known as perihelion. For 3i Atlas, perihelion was October 29th, 2025. At that moment, the object was moving at its maximum velocity through our solar system, a blistering 68 kilometers per second. That is fast enough to circle the entire Earth in less than 10 minutes. That is the speed at which gravitational potential energy gets converted into raw kinetic energy when you fall towards something as massive as our Sun. And that is exactly the moment when you would want to fire an engine, if you had one, to get the most dramatic change in your trajectory for the least amount of fuel. It's the point of maximum leverage, where a tiny push results in a massive change down the line. I want to be clear, I am not saying that 3i Atlas has an engine. I am saying that if it were a spacecraft, if it were a probe designed by an intelligent civilization, perihelion would be the single most important moment of its mission. It would be the moment to use its propulsion system, the moment when physics is on your side. And that moment, the moment of maximum orbital efficiency, happened to occur exactly when Earth-based observation was completely impossible, when every telescope on our planet, Every instrument we have pointed at the sky was blinded by the sun's glare. The object was hidden, completely concealed from us, for 2 full weeks centered on that critical moment. Think about that timing. Really think about it. An interstellar visitor arrives in our solar system on a trajectory that brings it closest to the Sun at the precise moment it is in solar conjunction from Earth's perspective. The optimal time for any kind of orbital maneuver coincides perfectly with the optimal time for concealment. In astronautics, we would call that mission design. We would call it brilliant planning. In nature, we are forced to call it an extraordinarily unlikely coincidence. But here is where it gets even more interesting. And this is the part that should make every single person listening right now sit up and pay serious attention. The Sun erupted with its most powerful flare of the year exactly as 3i Atlas was in that hidden perihelion window. Not before, not after, but during. The X5.1 flare that launched the Cannibal CME currently battering our magnetosphere came from a sunspot that had been relatively quiet and then suddenly, in the space of 3 days, produced 3 massive X-class eruptions. Could an interstellar object actually influence solar activity? The conventional answer from mainstream astrophysics is an immediate and definitive no. The Sun is incomprehensibly enormous. It contains 99.86% of all the mass in the entire solar system. 3i Atlas, even at the upper size estimates of 20 kilometers in diameter, is a microscopic speck of dust by comparison. Its gravitational influence is negligible. Its magnetic field interaction is effectively zero. There is no known physical mechanism by which a small, comet-sized object could trigger a solar flare from millions of kilometers away. But let me pose a different question. A question that turns the entire problem on its head. What if we are thinking about this backwards? What if 3i Atlas did not cause the solar activity? What if it was waiting for it? Solar maximum, the peak of the Sun's 11-year activity cycle, is happening right now in 2025. We have known this was coming for years. Solar physicists have been predicting increased flare activity, more sunspot formation, and higher rates of CMEs for months. This is a predictable, cyclical event. If you were an interstellar visitor, if you were a probe designed to study stellar systems, would you not time your closest approach for the period of maximum activity? Would you not want to observe the star at its most energetic, most dynamic, most interesting state? It would be like a biologist timing their visit to the Serengeti for the Great Migration. You go when the action is happening. The data we are seeing supports something remarkable and deeply unsettling. 3i Atlas arrives during solar maximum. It approaches perihelion during solar conjunction, when it cannot be observed from Earth. The Sun produces its strongest flare series of the year during that exact hidden window. The object then emerges showing impossible physical characteristics, multiple jets, including anti-sunward jets, and minimal tail despite a massive calculated mass loss. And now, as it moves back into observable space, Earth is being hit by the most severe geomagnetic storm of the year. Let me give you another piece of this puzzle that has not gotten nearly enough attention. The direction of arrival. 3i Atlas came from a specific region of space. When astronomers trace its trajectory backward, out of the solar system and into the galaxy, the galactic coordinates place its origin within 9 degrees of the famous WOW signal detected in 1977. That radio signal, a powerful, narrow band emission lasting for just over a minute at exactly the frequency of neutral hydrogen, remains completely unexplained to this day. It was so strong, so clearly artificial looking, that the astronomer who discovered it, Jerry Amon, famously wrote WOW in the margins of the data printout, giving the signal its name. For 48 years we have wondered what produced that signal. Was it some unknown natural astrophysical phenomenon? Was it terrestrial interference that somehow mimicked an extraterrestrial signal perfectly? Or was it something else? Now we have an interstellar object arriving from the same general direction of the sky, displaying deeply anomalous behavior, arriving precisely at solar maximum, hidden at perihelion, and emerging just as the Sun explodes with activity. The clustering of these anomalies, the stacking of improbabilities, is becoming incredibly difficult to dismiss as mere chance. But let us move from the cosmic scale down to something more immediate, something more visceral and potentially more dangerous. The geomagnetic storm hitting us right now is not just a light show. It is not just pretty auroras for people to photograph and post on social media. It is a massive injection of energy into Earth's magnetosphere, its ionosphere, and potentially much deeper into our planet's systems than most people realize. Research published in early 2025 from a team of scientists analyzing nearly a century of data found something extraordinary. There is a statistically significant correlation between intense geomagnetic storms and large earthquakes. Not an immediate connection, not on the same day, but approximately 27 to 28 days after a major storm, the probability of a large earthquake increases significantly. The lead researcher used a sophisticated method called shift neighborhood matching correlation to analyze decades of geomagnetic storm data against the global catalogue of magnitude 7.0 and larger earthquakes. The correlation held up. It was statistically significant. It was real. Now, before anyone panics, let me be very clear about what this research shows and what it does not show. It does not mean that geomagnetic storms directly trigger earthquakes. The mechanism is not that simple. What it suggests is that intense magnetic field disturbances at Earth's surface, particularly in the regions under the polar cusps where charged particles can penetrate deeper into the atmosphere, may influence the stress fields in the lithosphere through mechanisms we're only just beginning to understand. Two primary mechanisms have been proposed. One is the reverse piezoelectric effect, where electric fields induced in the ground by the storm create mechanical stress in crystalline rocks like quartz, which are common in fault zones. The other is electroosmotic flow, where charged particles in fluids within porous rock are moved by the electromagnetic gradients, altering fluid pressures and potentially weakening faults. These are real physical processes. The question is whether they are strong enough, sustained enough, to nudge already stressed fault systems over the threshold into rupture. The summer of 2025 provided a dramatic real-world test of this hypothesis. In June, multiple geomagnetic storms occurred, not as strong as what we are experiencing today, but significant G3 and G4 events. Then, in July and August, something unusual happened. 5 major earthquakes, all magnitude 7.0 or larger, struck in rapid succession. There was a magnitude 7.3 in Alaska, a 7.4 in Kamchatka, a 7.0 at Macquarie Island, a massive 8.8 in the Kamchatka Peninsula, and a 7.5 in the Drake Passage. Each of these earthquakes occurred in regions that were positioned under or near the polar cusp corridor during the June geomagnetic storm onsets. The time delays range from 30 to 74 days, well within the window that the correlation research predicted. One event in particular stands out. A magnitude 7.7 earthquake struck Myanmar on March 28, 2025. 83 days earlier, on January 4th, a geomagnetic storm began at 02:55 Universal Time. At that exact moment, the longitude range of 75 degrees east to 195 degrees east was positioned directly under the polar cusp. Myanmar sits at 95.9 degrees east, right in the middle of that corridor. 83 days later, the ground ruptured with devastating force. So here we are on November 12, 2025, in the middle of a G4 geomagnetic storm that may escalate to G5 if the most powerful part of the CME is still incoming. If this correlation holds, if the mechanism is real, we should expect an increased probability of major seismic activity starting in early to mid-December. That predicted seismic window, starting around December 9th or 10th, perfectly overlaps with the date that 3i Atlas makes its closest approach to Earth on December 19th. Is that a coincidence too? An interstellar object arrives at solar maximum, passes perihelion during solar conjunction, and emerges as record-breaking solar flares erupt. Those flares produce the strongest geomagnetic storm of the year, and that storm falls in the exact time window to potentially influence seismic activity right during the object's closest approach to Earth. How many coincidences do we need to accept before we start considering alternative explanations that are far more disturbing? Let me be absolutely clear about what I am, and am not suggesting here. I'm not saying that 3i Atlas is going to cause earthquakes. I am not predicting disaster or claiming some kind of cosmic attack. What I am saying is that the timing, the clustering of events, the statistical improbabilities stacking on top of each other deserves serious scientific attention rather than casual dismissal. When you have an object displaying 8 documented anomalies before perihelion, emerging with even more bizarre characteristics after perihelion, and that emergence coincides with major solar and geomagnetic activity that may influence seismic patterns exactly during its closest approach to Earth. The pattern demands investigation. The conventional scientific approach is to assume natural explanations until proven otherwise. That is good methodology. That is how science should work. But there is a difference between healthy skepticism and willful denial. There is a difference between requiring evidence and refusing to look at the evidence that already exists. 3i Atlas has given us plenty to look at. The question is whether we have the courage to look closely and consider what it might mean. Right now, tonight, as auroras ripple across latitudes that rarely see them, as power grid, operators watch voltage fluctuations with growing concern, as satellites maneuver to minimize their radiation exposure, something is happening that we have never witnessed before. An interstellar visitor is moving through our inner solar system during the peak of solar maximum, and our sun is responding with record-breaking violence. Whether that response is coincidental or causal, whether the timing is random or designed, those are the questions that will define how we understand our place in the galaxy. The data keeps coming in, the measurements keep accumulating, and the coincidences keep piling up in ways that make the word coincidence feel increasingly and dangerously inadequate. There is an image that every astronomy textbook shows when explaining what comets are. It is usually a breathtaking photograph of Comet Hale-Bopp or Comet Hyakutake, some magnificent visitor from the outer solar system making its rare and brilliant appearance in Earth's skies. The image always shows a bright nucleus, a glowing coma of gas and dust surrounding it, and most importantly, a spectacular tail stretching across millions of kilometers of space, always pointing directly away from the sun. That tail is the defining signature of a comet. It is the visual proof that solar radiation and the solar wind are actively pushing material off the icy nucleus. Without that tail, you do not really have a comet in the traditional sense. You have something else entirely. 3i Atlas does not have a tail. Not the way it should. Not the way physics demands it should after what it just endured at perihelion. Let me show you exactly how weird this is by comparing it to another comet that was being observed during the same time period. Comet Lemon, a perfectly ordinary, well-behaved member of our solar system's comet population, was photographed by the Anomalies Observatory on November 3, 2025. This was the same telescope that would image 3i Atlas just 2 days later. Comet Lemon's image is textbook perfect. It shows a clear nucleus, an extensive coma, and a beautiful sweeping dust tail arcing away from the sun exactly as radiation pressure predicts. The physics is working exactly as expected. Solar photons, particles of light, hit the dust particles ejected from the comet. A momentum transfer occurs, and the dust streams outward in the anti-solar direction. It is simple, it is predictable, it is normal. Then we have the image of 3i Atlas from November 5th. It is a fuzzy ball, a compact source of light with no obvious tail structure. The morphology is almost identical to the Hubble Space Telescope image from July 21st, which was taken when the object was still 277 million miles from Earth and nowhere near its closest approach to the Sun. It is as if the intense solar heating, the 770 watts per square meter of irradiance, the 33 gigawatts of total power delivery, had almost no visible effect on the object's appearance. But wait, you might say, maybe 3i Atlas is just not very active, maybe it is mostly rock with very little ice. Maybe the outgassing is minimal, so of course there is no big tail. That explanation would work perfectly if not for one critical, contradictory piece of data, the non-gravitational acceleration. When JPL analyzes the trajectory of 3i Atlas, when they fit all the observations to a mathematical model of its path through space, the model only works if they include a non-gravitational term. The object is accelerating in a way that gravity alone cannot explain. That acceleration has a specific measured value, and it is strong enough to shift the object's position by millions of kilometers over the course of its journey. It is strong enough to be detected at a high level of statistical significance, 3.7 standard deviations in the latest measurements. That is not noise. That is not a measurement error. That is a real physical push. For a natural comet, that push comes from the rocket effect of outgassing. Ice sublimates, gas jets out, momentum is conserved, and the comet accelerates. The measured acceleration tells you exactly how much mass is being ejected and how fast. The calculation is straightforward thermodynamics and momentum conservation. Based on the measured acceleration of 3I Atlas, more than 13% of its total mass must have been lost near perihelion. That is the number Avi Loeb calculated, and other researchers looking at the same data have arrived at similar conclusions. 13% of a 5 to 20 kilometer diameter object is an enormous amount of material. We are talking about hundreds of billions of tons of ice and dust being ejected into space. That material does not just disappear. It forms a cloud. It gets pushed by solar radiation. It creates structure. It creates a tail, a big, obvious, unmissable tail that should extend for millions of kilometers and should be clearly visible in all post-perihelion images. 3I Atlas does not have it. The cloud is not there. The tail is not there. The debris field that physics demands must exist is somehow absent, or at least invisible in a way that defies standard comet behavior. Then we get to November 8th, and the story gets even stranger. The image captured by Jagger, Reman and Prosper shows a large glowing halo extending out to 500,000 kilometers. That sounds like a coma. That sounds like exactly what we would expect from massive outgassing. But here is the problem. The structure is not symmetrical. It is not a simple expanding sphere of gas and dust. Instead, there are at least 7 distinct jets, 7 separate streams of material flowing in different directions. And some of those jets, multiple jets, are pointing directly toward the sun. Stop and think about that for a second. Solar radiation pressure pushes outward. The solar wind, the constant stream of charged particles flowing away from the sun, pushes outward. The entire environment around the sun is designed by physics to move material in one direction, away. And yet 3I Atlas is producing jets that flow sunward. These are called anti-tails in the literature, and while they can occur in normal comets under very specific geometric conditions, they are usually optical illusions. They are tail segments that appear to point sunward from Earth's viewing angle, but are actually still oriented in the anti-solar direction in three-dimensional space. The anti-tails of 3I Atlas are not optical illusions. The geometry does not work for that explanation. The sunward jets are real structures, real flows of material moving against the pressure gradient that should prevent them from existing. That requires force. That requires something actively pushing material toward the sun, overpowering the radiation pressure and solar wind that should be pushing it away. Now, let me connect this directly to what is happening right now with the geomagnetic storm. The Cannibal CME hitting Earth today is the result of multiple coronal mass ejections merging in interplanetary space. The first CME came from the X1.7 flare on November 9th. The second came from the X1.2 flare on November 10th. The third and most powerful came from the X5.1 flare on November 11th. Each ejection sent a cloud of magnetized plasma racing away from the sun. Each cloud carried its own magnetic field structure, frozen into the plasma as it expanded outward. When these clouds merge, when a faster cloud catches a slower one, the magnetic fields interact. They can reinforce each other, amplify each other, or they can reconnect in complex ways that release even more energy. The result is a structure in interplanetary space that is far more geo-effective, far more damaging to Earth's magnetosphere than any single CME would be alone. The particle density is higher, the magnetic field strength is stronger, the duration of the impact is longer. Everything about a Cannibal CME makes it more dangerous to our technological infrastructure. But here is the question nobody is asking publicly, even though I guarantee it is being discussed in private meetings at space weather centres around the world. Why did AR4274, the sunspot that produced these 3 flares, suddenly become so violently active right when 3I Atlas was at perihelion? Active regions on the sun are not random. They form where magnetic field lines emerge from the interior and break through the photosphere, creating the cooler regions we see as dark spots. The magnetic energy stored in these regions builds up over time as the sun's internal dynamo generates and twists the field lines. Eventually, that stored energy gets released through flares and CMEs. The process is well understood in general terms, even if predicting exactly when and where a flare will occur remains beyond our current capabilities. AR4274 existed for weeks before this major flare sequence. It was active, yes, producing smaller flares and showing magnetic complexity, but the sudden jump to 3 X-class flares In 3 days, culminating in the strongest flare of the year, was a dramatic and rapid escalation. Solar physicists will point to the complex magnetic field configuration, the beta-gamma-delta classification, indicating shearing and rotational motions that store enormous amounts of energy. All of that is true. All of that is standard solar physics. What is not standard is the timing. 3I Atlas reaches perihelion on October 29th. AR4274 erupts with an X1.7 flare on November 9th, 11 days later. It erupts again with an X1.2 flare on November 10th, 12 days later. And finally it erupts with the monster X5.1 flare on November 11th, 13 days later. Each flare occurs as 3I Atlas is emerging back into Earth's visible sky, moving away from solar conjunction. Each CME is launched on a trajectory that, when they merge, creates the perfect cannibal structure now impacting our planet. Could 3I Atlas somehow trigger solar activity? The physics says no. The gravitational influence is negligible. The magnetic field of a comet-sized object, even if it were somehow artificial and powered, would be microscopic compared to the Sun's vast field. There is no known mechanism for a small object to reach across millions of kilometers of space and induce flares in specific active regions, unless we're thinking about the wrong mechanism, unless the interaction is not gravitational or magnetic but something we have not yet considered, or unless the causation runs the other direction, unless something about the solar activity influenced 3I Atlas rather than the other way around. The 7-jet structure observed on November 8th is not a stable, frozen configuration. The jets are active, they are flowing, they are changing. That requires an ongoing input of energy. That requires continued outgassing, or continued thrust from some other mechanism. And it is happening exactly as the solar environment around 3I Atlas is being disturbed by the outbound propagation of the very same CMEs that are now hitting Earth. A CME expands as it moves away from the Sun. The one from the X5.1 flare has travelled roughly 150 million kilometres to reach Earth, but before it reached us, it passed through the orbital region where 3I Atlas is currently located. The object is currently about 1.5 astronomical units from the Sun, moving outbound. The CME would have encountered it first, washing over it with enhanced magnetic fields and particle densities far above the normal solar wind background. What happens when a massive CME impacts a small icy body? For a normal comet, probably not much. The comet is already outgassing in response to solar heating. The extra particle flux might enhance that process slightly, but it would not fundamentally change the comet's behaviour. But 3I Atlas is not behaving like a normal comet. It has no tail when it should. It has sunward jets when it should not. It has non-gravitational acceleration, requiring massive mass loss without the corresponding debris cloud. What if the CME interaction explains some of this? What if the magnetic fields carried by the coronal mass ejection are interacting with 3I Atlas in ways we do not expect, because the object is not what we think it is? A CME carries magnetic energy. If that energy can couple into a conductive object, if it can induce currents, if it can create electromagnetic forces, you could get thrust, you could get momentum transfer without any mass ejection, you could get acceleration without a visible tail. This is speculation, obviously. This is pushing the boundaries of what we know into the territory of what we can imagine. But the data is forcing us to imagine new possibilities, because the conventional explanations are simply not working. 3I Atlas is not behaving like a comet. The Sun is not behaving normally during this object's passage. The timing is not random. The correlations are too strong. The anomalies are stacking up too high. And now, as the Cannibal CME pounds our magnetosphere, as satellites report anomalies, as power grids fluctuate, as auroras dance in skies that rarely see them, we have to ask what happens next. What happens on December 19th when 3I Atlas reaches its closest approach to Earth? What happens in late December or early January if the geomagnetic storm-seismic correlation proves accurate and earthquake activity increases? What happens if more CMEs launch from active regions that keep flaring? The missing tail is not just a scientific curiosity. It is a signal that our understanding is dangerously incomplete. Something about 3I Atlas defies the physics we think we know, and that something is manifesting right now during the most intense space weather event of the year. The question sounds absurd on its face. How could a relatively tiny object, maybe 20 kilometers across at most, influence something as incomprehensibly massive and powerful as the Sun? The Sun contains 99 to 86% of all the matter in our solar system. It is a ball of plasma so vast that 1 million Earths could fit inside it. The magnetic fields threading through its interior and erupting from its surface carry energy measured in terms that make nuclear weapons look like firecrackers. The idea that a comet, an interstellar visitor, could somehow reach out and tickle the Sun into producing the most powerful flare of the year seems to violate every principle of physics we hold dear. And yet, let me show you why this question is not as crazy as it first appears. Solar flares are triggered by a process called magnetic reconnection. That is the fundamental mechanism. The Sun's magnetic field is not a simple, neat dipole structure like Earth's field. It is a tangled, twisted, sheared mess of field lines that are constantly being generated by the dynamo in the solar interior and constantly being shuffled and stressed by convective motions and differential rotation. When field lines with opposite polarity get pushed together, they can suddenly snap and reconnect into a new, simpler configuration. That reconnection event releases the enormous amount of magnetic energy that was stored in the previously stressed field configuration. Some of that energy goes into heating plasma to tens of millions of degrees, some of it goes into accelerating particles to nearly the speed of light, and some of it goes into ejecting billions of tons of material in a coronal mass ejection. The key word there is trigger. Magnetic reconnection does not create the energy. The energy was already there, stored in the twisted magnetic field like a wound-up spring. Reconnection just releases the restraint and lets the spring snap back, suddenly and catastrophically. You do not need a big trigger to release a lot of stored energy. You just need the right trigger, in the right place, at the right time. Now, here is where it gets interesting. There are documented cases of external disturbances triggering solar eruptions. In 2007, Comet Enki, a regular member of our solar system, passed through the Sun's outer atmosphere and temporarily had its tail ripped off when a CME slammed into it. But the story does not end there. Observations showed that the comet's interaction with the coronal magnetic field may have influenced subsequent activity in nearby active regions. The effect was subtle, hard to quantify, but it was there in the data. Small perturbations to the coronal magnetic structure were potentially affecting when and where the next reconnection event occurred. 3I Atlas came much closer to the Sun than Comet Enki ever does. At perihelion, the separation was just 1.36 astronomical units, about 203 million kilometers. That sounds like a lot, but on solar system scales, it is intimate. The object passed through regions of space where the Sun's extended magnetic field, the heliospheric current sheet, is still organized and strong. If 3I Atlas carries any magnetic field of its own, or if it is electrically charged, or if its coma of ionized gas interacts with the ambient solar wind, then it could potentially perturb the local magnetic environment. Small perturbations can cascade. That is a fundamental principle of complex systems. When a system is already in a critical state, already loaded with energy and teetering on the edge of instability, a tiny push can trigger a very large response. Active region AR4274 was in exactly that state. The magnetic shear was building. The energy was accumulating. The field lines were being twisted and compressed into a beta-gamma-delta configuration that practically screams imminent eruption. All it needed was a trigger. What if 3I Atlas provided that trigger? Let me walk you through a scenario, a what-if story grounded in real physics, even if we cannot prove it happened this way. 3I Atlas approaches perihelion on October 29th. As it does, its trajectory carries it through the heliospheric plasma, the extended atmosphere of the Sun. If the object is outgassing, if it is releasing ions and electrons and neutral atoms that then get ionized by solar ultraviolet radiation, it is creating a local disturbance in the solar wind. It creates a wake, a region where the particle density, the flow velocity, and the magnetic field topology are all perturbed compared to the undisturbed solar wind. That wake propagates. It flows outward with the solar wind, but it also has transverse components. It creates ripples in the magnetic field structure. Those ripples travel along the magnetic field lines at what is called the Alfvén speed, the speed at which magnetic disturbances propagate through a magnetized plasma. For the solar wind near Earth, that speed is typically around 50 to 100 kilometers per second. It is fast, but it is not instantaneous. A ripple initiated at the position of 3 Psi Atlas could take hours, or even days, to propagate back to the Sun's surface, depending on the connectivity of the field lines. Now, AR4274 sits on the Sun's surface, roughly halfway between the equator and the North Pole, at a longitude that happens to be magnetically connected to the region of space 3I Atlas is moving through. The connection is not a straight line, but follows the Parker spiral, the Archimedean spiral shape the Sun's magnetic field takes as the Sun rotates and the solar wind flows outward. These field lines are like highways for plasma and disturbances to travel along, and on November 9th, 11 days after 3I Atlas reaches perihelion, AR4274 erupts with the X1.7 flare. Coincidence? Quite possibly. But here is where it gets much harder to dismiss. The active region does not just flare once, it flares 3 times in 3 days, each one more powerful than the last. That escalation pattern is consistent with the system responding to a sustained external disturbance. Each flare releases some of the stored magnetic energy, but not all of it. The field partially relaxes, then builds up again, stressed by the continued disturbance, until finally on November 11th, the X+.1 flare releases everything in one catastrophic reconnection event. The timing of this escalation matches the timeline of 3I Atlas moving through perihelion and then away, still interacting with the solar wind environment, still potentially perturbing the magnetic field structure in ways that feed back to the active region. If the object is doing anything unusual, anything that creates a larger disturbance than a normal comet would, then the effect would peak around perihelion and persist for days afterward as the disturbed plasma and field lines continue to evolve and propagate. What could create a larger than normal disturbance? Well, if 3I Atlas has any kind of internal magnetic field, that would do it. Natural bodies like comets do not generally have strong fields, but if this object is not entirely natural, if there is any technological component, any power source, any active systems, then magnetic fields become possible. Even a modest field, say a few hundred nanoteslas, would be enough to significantly alter the local plasma environment and create disturbances that propagate outward. Alternatively, if 3I Atlas is electrically charged, that would also amplify its interaction with the solar wind. Objects in space naturally accumulate charge from photoemission and plasma interactions, but usually the charge is small and the effects are minor. However, if an object has a large surface area to mass ratio, if it has materials that are particularly efficient at photoemission, or if it has any active charge management systems, it could carry a substantial net charge. A charged object moving through a magnetized plasma creates electric fields, drives currents, and generates electromagnetic forces that perturb the surrounding medium far more than a neutral object would. There is another possibility, more exotic but worth considering. 3I Atlas might be affecting the Sun not through electromagnetic interactions, but through gravitational ones, specifically through tidal effects on the solar plasma. Now, I know what you're thinking. The tidal force from such a small object at that distance would be utterly negligible. And you are right, for a solid body. But the Sun is not solid. It is a fluid, a magnetized plasma with complex internal dynamics. Tidal forces, even tiny ones, can potentially interact with resonances in the solar interior, with oscillation modes, with convective flows. If the frequency and spatial pattern of the tidal disturbance happen to match a natural mode of oscillation in the Sun, you could get resonant amplification. Small cause, large effect. This is not mainstream solar physics, this is speculative, edge-of-knowledge territory. But the mainstream explanations are not working for 3I Atlas. The object is too anomalous, the timing is too perfect, the correlations are too strong to dismiss as mere chance. Let me give you another piece of the puzzle. The X5.1 flare was not just powerful, it was directional. The associated CME was classified as an asymmetric halo CME, meaning the ejection was not symmetrically distributed around the Sun as seen from Earth. It had a preferred direction, and that direction was aimed almost directly at Earth. Not at Mars, which is closer, not into interplanetary space at some random angle, but at Earth. Now, CMEs can be aimed in any direction depending on the geometry of the eruption. There is nothing inherently suspicious about one being Earth-directed, except that 3I Atlas is on a trajectory that will bring it closest to Earth on December 19th. The object's path through the solar system carries it past Venus, then Earth, then on toward Jupiter. The CME that erupted as 3I Atlas emerged from perihelion is now racing ahead of it, arriving at Earth first, preparing the space environment, disturbing our magnetosphere, and potentially setting up geomagnetic-induced seismic activity that will peak right around the time the object itself makes its close approach. If you were designing a mission, if you were planning an observation campaign or a reconnaissance operation, or honestly anything that required understanding how a planet responds to space weather stress, you would do exactly this. You would send a disturbance ahead, watch how the system reacts, measure the response, and then arrive yourself during the aftermath to take more detailed measurements while the system is still disturbed and easier to probe. I am not saying that is what is happening. I am saying the pattern looks uncomfortably like what we would do if we were in their position, and that should give us pause. The sun produces flares. The sun is in solar maximum. Active regions build up energy and release it through reconnection. All of that is normal. What is not normal is the precise timing with an interstellar visitor's perihelion passage. What is not normal is the escalation pattern over 3 days. What is not normal is the direction of the most powerful CME pointing at Earth, just as the object heads toward Earth itself. We are trained in science to look for the simplest explanation, the one that requires the fewest assumptions, Occam's razor. The simplest explanation here is coincidence. Everything is just random chance lining up in ways that look meaningful but actually are not. The sun flared because active regions flare. The timing matched 3I Atlas because there are always interstellar objects passing through somewhere, and if we look hard enough we can find correlations with anything. But Occam's razor also says we should not multiply entities beyond necessity. We should not invent new physics without reason, and yet 3I Atlas is forcing us to do exactly that. The object does not behave like a comet. It does not follow the rules. And now the sun is not following the rules either, erupting with record-breaking power at exactly the wrong time to be a coincidence if this object is anything other than what mainstream science assumes it is. The data is screaming at us to pay attention. The patterns are too clear. The anomalies are too numerous. Whether 3I Atlas actually triggered the solar outburst through some mechanism we do not yet understand, or whether something else is orchestrating both the object's behavior and the solar activity in a coordinated way, either possibility takes us into territory science is deeply uncomfortable exploring. But uncomfortable or not, the question is now unavoidable. On the morning of November 2nd, 2025, at 4:36 Universal Time, an astronomer in Crimea detected a faint, moving object in the pre-dawn sky. His name is Gennady Borisov, and if that name sounds familiar to you, it should. This is the very same individual who discovered 2I Borisov back in 2019, the first confirmed interstellar comet to visit our solar system after the enigmatic Oumuamua. Borisov has a proven track record. He knows what he's looking at when he finds something unusual, and what he found on November 2nd is very, very unusual. The object is now officially catalogued as C2025 V1, Borisov, and its timing could not be more perfect or more suspicious, depending on your perspective. Think about what was happening in our solar system on November 2nd. 3I Atlas had reached perihelion just 4 days earlier, on October 29th. It was still completely hidden behind the sun from our view, still deep in solar conjunction, still utterly unobservable from our planet. The solar activity that would soon explode into the X-class flare sequence was just beginning to build in active region AR4274. And into this precise moment, this narrow window of time when everything was shifting and changing, a new comet appears. It does not appear just anywhere, not in some random part of the sky. C2025 V1 Borisov was discovered positioned in space along a rough line between Earth and 3I Atlas. The geometry is striking. If you map out the positions of all three objects, Earth, Borisov and 3I Atlas, they form a rough, almost collinear arrangement through space. Borisov sits in the middle, approximately 106 million kilometers from Earth when it was discovered, moving on a trajectory that would bring it to its closest approach to our planet just 9 days later, on November 11th. The orbit itself is strange. The eccentricity is listed as 1/20958273. For those not steeped in orbital mechanics, let me explain what that number means. An eccentricity of exactly 1.0 defines a parabolic orbit, which is the precise boundary between a bound and an unbound trajectory. If the eccentricity is less than 1, the object is gravitationally bound to the Sun, destined to return someday, perhaps in thousands or millions of years. If the eccentricity is greater than 1, the object is on a hyperbolic escape trajectory, visiting our solar system just once and then never coming back. Borisov's eccentricity is greater than 1, but just barely. It is what astronomers are calling nearly interstellar. That phrase, nearly interstellar, is doing a lot of work. It means the object is not quite unbound from our solar system, but it is very, very close to it. It probably originated in the Oort cloud, the distant spherical shell of icy debris that surrounds our solar system far beyond the planets. Objects from the Oort cloud occasionally get gravitationally perturbed by passing stars or galactic tides and fall inward toward the Sun. Most of them stay bound. Some of them get accelerated to escape velocity by close encounters with planets like Jupiter. Borisov is right on that boundary, moving so fast that its future is uncertain. It might escape into interstellar space. It might stay bound in a very long period orbit. The measurements are not quite precise enough yet to say for sure. But here is what makes it so interesting. Beyond the orbital parameters, Borisov has no clear tail, just like 3i Atlas. Observations from multiple amateur astronomers and professional surveys show a faint coma, a fuzzy glow around the nucleus, but no extended tail structure. Its apparent magnitude is around 13.8, far too faint for naked eye visibility, but easily detectable with modest telescopes. The coma diameter is measured at 2.3 arc minutes. All of this suggests some level of cometary activity, some outgassing, but it is subdued, quiet. It is not the dramatic display you would expect from a comet making a close pass by the Sun. Borisov will reach its own perihelion on November 16th, just 4 days from now. At that point, it will be about 0.46 astronomical units from the Sun, roughly 46% of Earth's orbital distance. That is close. That is inside the orbit of Mercury at its farthest point from the Sun. The solar irradiance at that distance is intense, more than enough to vaporize volatile ices and drive significant outgassing. If Borisov is a normal comet, we should see it brighten dramatically over the next few days. We should see a tail develop. We should see all the classic signs of a comet responding to intense solar heating. If it does not, if Borisov remains tailless and quiet even at perihelion, then we will have another major anomaly to add to the growing list. 2 objects, one definitely interstellar and one nearly so, both displaying suppressed cometary activity, both present in the inner solar system at the same time, both discovered within a narrow window of each other. The distance between their orbits at the closest point is about 75 billion kilometers. That is half an astronomical unit, the distance from the Earth to the Sun divided by 2. In cosmic terms, that is practically next door. The objects themselves, accounting for their positions in time rather than just their orbital geometry, were never closer than about 225 million kilometers from each other. That is our 1.5 astronomical units. Still close on solar system scales, close enough that if there were any kind of communication or coordination between them, the light travel time would be manageable. It would take just 12.5 minutes for a signal to cross that distance. Now, let me be very clear about what the mainstream scientific position is on Borisov. It is a comet. It originated in our solar system's Oort cloud. The orbital eccentricity being slightly above 1 is not evidence of interstellar origin, but rather indicates a gravitational interaction, possibly with Jupiter or another giant planet, that boosted its speed to near escape velocity. The fact that it was discovered by the same astronomer who found the previous interstellar comet is a coincidence, a testament to Gennady Borisov's skill and dedication to comet hunting, and nothing more. The lack of a prominent tail is just due to its composition and its distance from the Sun at the time of observation. Everything is normal, everything is explainable, except Avi Loeb, the Harvard astrophysicist who has been the most prominent voice questioning the mainstream narrative on 3i Atlas, immediately raised a different, more provocative question when Borisov was announced. Could the 2 objects be related? Could C2025 V1, Borisov, have been deployed by 3i Atlas during its hidden perihelion passage? The word deployed is loaded. It implies intentionality. It implies technology. It implies mission architecture. But set aside the implications for a moment and just look at the mechanics. 3i Atlas reaches perihelion on October 29th. It is hidden from Earth observation for approximately 2 weeks, before and after that date due to solar conjunction. During that hidden window, it experiences the most intense solar radiation of its journey. It displays the bizarre 7-jet structure, suggesting that material is being ejected in multiple controlled directions. And then, on November 2nd, just 4 days after perihelion, a new object appears, positioned along a roughly aligned trajectory between Earth and 3i Atlas. If you were a mothership, if you were an interstellar probe designed to study stellar systems, perihelion would be the logical time to deploy smaller subprobes. You are already at your closest approach to the star. You're moving at your maximum velocity. You have the most energy available for velocity changes due to the Oberth effect. And critically, you are hidden from observation by the primary planet you're interested in studying. Earth cannot see you. You can do whatever you need to do without detection. You can launch probes, adjust your trajectory, execute maneuvers, all while Earth's telescopes are blinded by the sun's glare. Loeb calculated the separation between the orbits of 3i Atlas and Borisov and found that minimum value of 75 million kilometers. He noted that the measured non-gravitational acceleration of 3i Atlas is insufficient to bridge that gap without additional propulsion. In other words, if Borisov came from 3i Atlas, it would require its own propulsion system. It could not have been a passive ejection, riding only on the momentum of outgassing from the parent body. It would need to be something capable of independent trajectory control. The mainstream response to this suggestion was immediate and emphatic. There is no evidence of a relationship between the two objects. Their orbital planes are nearly perpendicular to each other. Borisov is inclined at 112.7 degrees to the ecliptic, while 3i Atlas is in a retrograde orbit just 5 degrees from the ecliptic. They are moving in fundamentally different directions. The idea that one came from the other requires extraordinary propulsion that would leave obvious signatures we do not see. But do we not see them? Borisov, like 3i Atlas, has no clear tail. If it is using some form of propulsion, some method of trajectory control that does not involve conventional chemical rockets or even ion drives, then the signatures might not be what we expect. They might not be visible as an exhaust plume or a debris trail. They might manifest as anomalies in the non-gravitational acceleration, as unexplained brightness variations, as a trajectory that does not quite fit the purely gravitational models. The measurements are still preliminary. Borisov was only discovered 10 days ago. The orbital solution is based on a limited number of observations. As more data comes in, as more observatories track the object, the orbit will be refined. If the eccentricity drops below 1 in the refined solution, that would support the Oort cloud origin hypothesis. If it stays above 1, or if it trends even higher, that would strengthen the nearly interstellar classification. And if non-gravitational acceleration shows up in the tracking data, if Borisov deviates from a purely gravitational trajectory in ways that cannot be explained by normal outgassing, then the questions get much harder to dismiss. Right now, tonight, as the G4 geomagnetic storm continues to batter Earth's magnetosphere, Borisov is reaching its closest approach to our planet at a distance of 103 million kilometers. That is not close enough to be a threat. It is not close enough for any gravitational interaction. But it is close enough for detailed observation. It is close enough for spectroscopy. It is close enough to measure its composition, its brightness, its activity level. It is close enough to compare it directly with 3i Atlas and see if there are any chemical or physical similarities that might suggest a common origin. Multiple observatories around the world are pointed at Borisov tonight. Data is being collected, spectra are being analysed, and in 4 days, on November 16th, the object reaches perihelion, and we will see how it responds to intense solar heating. That will be the test. That will tell us if Borisov is just a normal Oort cloud comet that happened to show up at an interesting time, or if it is something else. Something related to the larger mystery unfolding around 3i Atlas. The geometry bothers me. The timing bothers me. The lack of a tail on both objects bothers me. The fact that they appeared in our inner solar system during the same narrow window, during solar maximum, during the most intense space weather event of the year, during a period when 3i Atlas was hidden and could have done anything without observation, all of it bothers me in ways that coincidence does not adequately explain. Two nearly interstellar objects, two tailless visitors, two pieces of a puzzle we do not yet understand, and between them, us, Earth, watching, wondering, and waiting to see what happens next. There is a concept in military strategy and in advanced space operations called distributed sensing. Instead of building one massive complex satellite with all of your sensors on board, you build multiple, smaller, simpler satellites and you spread them out. Each one carries a subset of instruments. Each one observes the target from a different position. Together, they create a sensor network that can see more, measure more, and understand more than any single monolithic platform could ever hope to achieve. The separation between the satellites provides a long baseline for interferometry, allowing for incredibly high-resolution imaging. The difference in viewing angles allows for stereoscopic ranging and three-dimensional mapping. The redundancy of the system protects against single-point failures. Distributed systems are more robust, more capable, and harder to defeat than centralized ones. What if that is what we are looking at with 3i Atlas and Borisov? The idea sounds like science fiction. It sounds like the kind of wild speculation that gets you laughed out of academic conferences and labelled a conspiracy theorist on social media. But let me walk you through why it is not as absurd as it first appears, why the data we have right now, today, supports at least considering this possibility seriously. First, let's look at the spatial distribution. 3i Atlas and Borisov are separated by roughly 225 million kilometers at their closest approach in time. That is 1.5 astronomical units. On the scale of our solar system, that is a significant baseline if you wanted to conduct interferometric observations of the Sun. If you wanted to measure the Sun's magnetic field structure with extremely high spatial resolution. If you wanted to characterize the three-dimensional distribution of the solar wind and coronal mass ejections, a baseline of 1.5 AU would give you incredible resolving power. You could see details, measure gradients, and map out structures that would be completely impossible to detect from a single vantage point. Now, both objects are supposedly natural. Both are supposedly just comets, chunks of ice and rock doing what comets do, but both are displaying deeply anomalous behavior. 3i Atlas has no tail when it should. It has 7 jets pointing in impossible directions. It has non-gravitational acceleration that requires a massive mass loss, but without the corresponding debris cloud. Borisov has no clear tail either. It is on a nearly interstellar trajectory, and it appeared exactly in the time window when 3i Atlas was hidden behind the Sun and at its most active. The timing is what elevates this from wild speculation to a legitimate hypothesis. Let me lay out the timeline with precision, because the details matter enormously. On October 29th, 3i Atlas reaches perihelion. It is at its peak solar irradiance, its peak velocity, and in the optimal position for any kind of maneuver or deployment. On November 2nd, just 4 days later, Borisov is discovered. On November 8th, 3i Atlas displays the bizarre 7-jet structure. On November 9th, the solar flare sequence begins. On November 11th, the X5.1 flare erupts, and Borisov reaches its closest approach to Earth. On November 12th today, the Cannibal CME hits Earth, while both objects are in perfect positions to observe the impact. Every single event in that timeline serves a clear purpose if you assume a distributed sensing mission. 3i Atlas goes through perihelion and potentially deploys Borisov. The deployment happens while Earth cannot observe it. Borisov moves into position between Earth and 3i Atlas, creating the observational baseline. 3i Atlas then displays activity, the 7 jets, that could be communications, course corrections, or active sensing operations. The Sun erupts, possibly triggered, possibly coincidental but conveniently timed. The CME propagates outward, passing through the region both objects occupy, allowing them to measure its structure and composition in situ, directly in space. Then the CME hits Earth, creating a geomagnetic storm that both objects can observe remotely through the auroral emissions, the magnetosphere's response, and the ionospheric disturbances. If you were designing a mission to study a star and its planets, this is exactly how you would do it. You would not send one probe, you would send multiple. You would position them strategically. You would time your observations to capture dynamic events, not just steady-state conditions. You would want to see how the system responds to stress, to perturbations, to extreme space weather, and you would do it during solar maximum when the star is most active and the data is richest. The 7-jet structure observed on November 8th deserves much more attention in this context. Jets from comets are usually explained by localized outgassing from active areas on the nucleus's surface. As the nucleus rotates, different areas face the sun, heat up, and release gas. The pattern of jets reflects the distribution of volatile-rich regions and the rotation state of the nucleus. But 7 distinct jets, some pointing sunward, all active simultaneously, that is very hard to explain with simple solar heating. It suggests something more organized, something more controlled. What if those jets are not outgassing at all? What if they are propulsion systems? What if they are communication beams? What if they are sensor arrays conducting active measurements of the solar wind environment? The energy requirements would be substantial, but not impossible for a technological system with a power source. The 33 gigawatts of solar energy hitting 3I Atlas at perihelion is more than enough to run any conceivable sensor suite or propulsion system. You would just need solar panels, or their equivalent, to collect it. The lack of tails on both objects becomes less mysterious in this framework. If the acceleration is not coming from passive outgassing but from active propulsion, you would not necessarily produce a visible exhaust plume. Ion drives, for example, produce thrust by accelerating ions to very high velocities. The exhaust is there, but it is diffuse, faint, and very hard to see except with specific instruments looking for specific signatures. Electric propulsion, magnetic field interactions with the solar wind plasma, even more exotic concepts like light sails or magnetic sails, all of these produce thrust without the dramatic visible exhaust of chemical rockets. Now, let me address the obvious objection. If these are technological objects, if they are probes or sensors or whatever you want to call them, why have we not detected any radio transmissions? We have radio telescopes. We have SETI programs that are constantly scanning the skies for extraterrestrial signals. If 3I Atlas and Borisov are communicating, either with each other or back to wherever they came from, we should be able to detect it, right? Maybe, or maybe not. Communication technology does not stand still. Our own technology has evolved from omnidirectional broadcasts to highly directional beams to spread spectrum techniques that look just like noise unless you know the encoding scheme. An advanced civilization would presumably have communication methods far beyond ours. They might use tight beam masers that only hit the intended receiver. They might use quantum entanglement for instantaneous communication that produces no detectable signal in normal space. They might use modulation schemes or frequency bands that we have not even thought to look in. The absence of evidence is not evidence of absence, especially when we do not really know what we should be looking for. There is also the possibility of optical communication. Lasers are highly directional, have high bandwidth, and are very hard to detect unless you are directly in the beam path or specifically looking for them with the right instruments. 3I Atlas and Borisov could be exchanging petabytes of data via laser links, and we would never know unless we happen to be in exactly the right position, with a telescope pointed in exactly the right direction at exactly the right time. The probability of a casual detection is essentially zero. But perhaps we have detected something and not recognized it for what it is. The brightness variations of 3I Atlas have been measured and catalogued. Some of those variations could be rotational, as the nucleus tumbles and presents different surface areas to our view. But some might be something else. They could be deliberate modulation, signaling, or orientation changes as the object points different instruments in different directions. Without high-cadence photometry, without continuous monitoring, we would miss most of this. We would just see a fuzzy blob that gets slightly brighter and dimmer over time, and assume it is normal cometary activity. The spectrum of 3I Atlas has shown unusual features, such as a high nickel abundance and low iron. These compositional anomalies have been noted and debated. Natural explanations invoke different formation environments, different stellar nurseries with different chemical enrichment histories. Technological explanations invoke manufactured materials, alloys, and structural components made from whatever elements are convenient or optimal for the design requirements. Both explanations fit the data. Both are consistent with what we observe. The question is which one requires fewer unsupported assumptions. Here is another piece that does not get talked about enough: the trajectory. 3I Atlas came from the same general direction as the WOW signal, with only a 9-degree separation on the celestial sphere. That is close. That is well within the pointing uncertainty of the original WOW signal detection. 48 years ago, a radio telescope in Ohio detected 6 minutes of intense, narrow-band emission at 1.420 GHz, the hydrogen line, one of the most logical frequencies for interstellar communication. The signal was strong, showed a Doppler shift consistent with an extraterrestrial source, and it never repeated despite extensive follow-up searches. What if the WOW signal was not a message? What if it was propulsion? What if it was the exhaust from a braking maneuver as 3I Atlas decelerated from interstellar cruise velocity to solar system insertion velocity? That would explain why it was so brief. That would explain why it never repeated. And that would mean 3I Atlas has been en route for 48 years, with plenty of time to arrive during solar maximum, plenty of time to coordinate with whatever mission parameters guided its launch. Borisov appearing now in this window, positioned along the trajectory between 3I Atlas and Earth, creates opportunities for coordinated observations that would not exist with either object alone. If you wanted to measure the propagation speed of the CME through the inner solar system, you would need multiple measurement points. If you wanted to characterize how Earth's magnetosphere couples to the solar wind, you would need simultaneous measurements of the incoming flow and the terrestrial response. If you wanted to understand the three-dimensional structure of the Sun's magnetic field during an active period, you would need widely separated vantage points. The objects are giving us exactly the geometry required for that kind of advanced study. Whether by design or by a staggeringly unlikely coincidence, we now have two anomalous visitors in our inner solar system. Both are positioned to observe the most significant space weather event of the year from different angles. Both are capable of measuring the solar wind and CME environment in situ. Both are potentially capable of observing Earth's response remotely. If this is coordination, if this is a planned campaign, then what comes next should be predictable. We should see more activity, more anomalies, more data collection opportunities timed to coincide with events we can independently verify. The December 19th close approach of 3I Atlas to Earth would be an obvious milestone. Borisov's perihelion on November 16th is another. If either object does something unexpected at those times, something that serves an obvious scientific or reconnaissance purpose, that would be powerful evidence. But we have to be watching. We have to be paying attention with the right instruments. We have to be willing to consider the possibility that what we are seeing is not natural. Because if we dismiss it out of hand, if we cling to the simple comet explanation, despite the mounting anomalies, we will miss it. We will miss the most important discovery in human history because we were too committed to our preconceptions to recognize what was right in front of us. Two objects, anomalous behavior, perfect timing, ideal positioning. The pattern is there. The question is whether we have the courage to see it. The connection between space weather and terrestrial effects has been studied for over a century. We have known for a long time that geomagnetic storms can disrupt power grids, damage satellites, interfere with radio communications, and create beautiful auroras. These are direct, immediate effects of charged particles and electromagnetic fields interacting with our technological infrastructure and our upper atmosphere. What we have not known, what has been dismissed as impossible by most geophysicists for decades, is whether space weather can reach down into the solid Earth and influence seismic activity. A paper published in Geophysical Research Letters in March of 2025 changed that entire conversation. The research team, led by scientists analysing nearly a century of data, introduced a new and powerful statistical method called shift neighbourhood matching correlation. They applied this method to two enormous datasets: the record of intense geomagnetic storms as measured by the disturbance storm time, or DEST index, and the global catalogue of earthquakes magnitude 7.0, and larger from the comprehensive catalogues maintained by seismological agencies worldwide. The question they asked was simple: is there any temporal relationship between major geomagnetic storms and major earthquakes? The answer was not what most scientists expected. Yes, there is a relationship, and it manifests with a very specific and surprising time delay. Approximately 27 to 28 days after an intense geomagnetic storm, the probability of a large earthquake increases significantly. Not immediately, not the same day, or even the same week, but roughly 1 lunar month later, the likelihood of a major seismic event goes up. Let me be very clear about what this research does and does not show. It does not prove that geomagnetic storms cause earthquakes. Correlation is not causation, and the researchers are very careful to emphasize that point. What it shows is that the timing is not random. When you have a major storm, the probability distribution of subsequent earthquakes is statistically different from the background rate. The peak in that probability occurs around day 27 to 28 after the storm's onset. The effect is robust across multiple statistical tests. It holds up when you vary the threshold for what counts as a major storm. It persists when you look at different subsets of the earthquake catalogue. The binomial distribution probability analysis confirms the result is significant. The t-squared test confirms it. When the researchers replaced the real earthquake data with randomly generated synthetic earthquake catalogues, the correlation completely disappeared, which tells you that something real about the timing of the earthquakes is creating this signal. This is not an artifact of the analysis method. This is a genuine temporal pattern in the Earth's behaviour. Now, the critical question is the mechanism. How could a geomagnetic storm, an event happening hundreds of kilometres above Earth's surface, in the ionosphere and magnetosphere, possibly influence tectonic processes happening kilometres below the surface in the solid crust and upper mantle? The energy scales seem wrong, the physics seems impossible, and yet the correlation exists. The paper discusses two potential physical mechanisms. The first is the reverse piezoelectric effect. Piezoelectricity is a property of certain crystalline materials, including quartz, which is incredibly abundant in Earth's crust. When you apply mechanical stress to these crystals, they generate an electric field. That is the piezoelectric effect. The reverse also works. If you apply an electric field to the crystal, it deforms mechanically. It changes its shape ever so slightly. During a geomagnetic storm, powerful electric currents are induced in the conductive layers of the Earth. The changing magnetic field from the storm creates electric fields according to Faraday's law. Those electric fields drive currents through the ground, through the rock, through the same crustal layers where tectonic stress is already accumulated and waiting to be released in an earthquake. If those induced electric fields interact with piezoelectric minerals in a fault zone, they could create tiny mechanical stresses, tiny deformations. These would not be enough to cause an earthquake on their own, but they could be enough to nudge a fault that is already critically stressed, already teetering on the very edge of failure. The second proposed mechanism is electroosmotic flow. This involves the movement of fluids through porous rock, driven by electric fields. Earth's crust is not solid and impermeable. It is fractured, it is porous, and it is filled with fluids in the pore spaces between the mineral grains. Those fluids are usually salty and therefore electrically conductive. When you apply an electric field, the charged ions in the fluid experience a force and start to move. This creates a pressure gradient, a flow of fluid from one region to another. Fluid pressure is enormously important in earthquake physics. It is one of the primary factors controlling the strength of a fault. When pore fluid pressure increases, it effectively reduces the normal stress across the fault surface, making it easier for the fault to slip. Hydraulic fracturing, or fracking, has demonstrated this principle dramatically. When you inject fluid into the subsurface, you increase the pore pressure, and you can trigger earthquakes that would not have happened otherwise. Electroosmotic flow, driven by the electric fields induced by a geomagnetic storm, could, in principle, redistribute fluids in the crust over a period of days to weeks, changing pore pressures, altering the loading on faults, and increasing the probability of rupture. Both of these mechanisms are speculative. Both require conditions that may not be met in most places most of the time, but they are grounded in real physics. They involve well-understood phenomena like piezoelectricity and fluid flow. The question is whether the magnitudes are sufficient, whether the geometry is right, and whether the cumulative effect over days can build up to something significant. The 27 to 28 day delay is particularly intriguing because it suggests a process that is not instantaneous but requires time to develop. Electric currents induced on day one might redistribute charge, create small deformations, and initiate fluid movements that then evolve over the following weeks. Stress builds up, pore pressures change, and fault systems that were stable slowly become unstable. Then, roughly a month later, something slips. There is also a specific geographic pattern to this correlation. The effect is strongest for earthquakes that occurred in regions that were positioned under the polar cusp during the onset of the geomagnetic storm. The polar cusp is a funnel-shaped region in Earth's magnetosphere, near the magnetic poles, where the field lines open up and allow charged particles from the solar wind to penetrate deeper into the atmosphere than they can elsewhere. If the particles can get deeper, if the energy deposition occurs at lower altitudes, then the coupling to the solid Earth could be stronger, the induced currents could be larger, and the effects could be more pronounced. A detailed study published in July 2025 examined this geographic dependence. The researchers identified the longitudinal corridor corresponding to the polar cusp at the time of each major geomagnetic storm over a multi-year period. Then they tracked where large earthquakes occurred in the weeks and months following. The correlation was clear. Earthquakes were more likely to occur in the regions that had been under or near the cusp during the storm's onset. The time delays range from a few days to about 2.5 months, with a clear concentration around 3 to 4 weeks. Real-world examples make this concrete. On January 4th, 2025, a geomagnetic storm began at 02:55 Universal Time. The polar cusp at that moment covered longitudes from 75 degrees east to 195 degrees east. 83 days later, on March 28th, a magnitude 7.7 earthquake struck Myanmar at 95.9 degrees east longitude, right in the middle of the predicted vulnerable corridor. The summer of 2025 provided even more dramatic evidence. Multiple geomagnetic storms in June, none of them quite as strong as what we're experiencing right now, but still significant, were followed by an unprecedented cluster of large earthquakes in July and August. There were 5 events of magnitude 7.0 or greater in rapid succession. The July 16th Alaska quake, the July 20th Kamchatka quake, the July 28th Macquarie Island event, the massive magnitude 8.8 Kamchatka earthquake on July 29th, and finally the August 22nd Drake Passage quake. Each one of these earthquakes occurred in a region that was under the polar cusp corridor during one of the June storm onsets. The time delays varied, but they all fell within the window that the correlation research predicted, from 30 to 74 days after the storms. It is hard to look at that cluster and call it a coincidence. It is hard to ignore the pattern. Now let me connect this directly to what is happening right now. The G4 geomagnetic storm hitting Earth today, November 12, 2025, is one of the most intense events of the year. The Deist index, the measure of the ring current enhancement that defines storm strength, is dropping to values we have not seen in months. The auroral oval has expanded to latitudes that rarely experience auroras. The polar cusps are active, energized, and funneling particles deep into our atmosphere. The induced currents in the ground are substantial, measurable, and creating electric field perturbations that sensitive instruments can detect. If the correlation holds, if the mechanism is real, we should expect an increased probability of seismic activity starting around December the 9th or 10th. That is 27 days from now. The window of increased probability extends out to roughly mid-January, covering the period from 27 to maybe 70 or 80 days post-storm. And critically, that window includes December 19th, the date that 3i Atlas makes its closest approach to Earth. The longitude that is under the polar cusp right now, at this moment, is sweeping across the globe as Earth rotates. Over the next 24 hours, every longitude will spend some time in that vulnerable corridor. But the regions that are under the cusp during the peak of the storm, during the hours when the Deist index is most negative and the particle precipitation is most intense, those regions should theoretically be at the highest risk for subsequent seismic activity. The west coast of North America is rotating into the cusp region within the next few hours. Japan and the Western Pacific will be there tomorrow. The Himalayan region, the Mediterranean, the west coast of South America, all will pass through at various times as Earth rotates beneath the auroral oval. If a major earthquake occurs in any of these regions in late December or early January, the correlation will have been validated in real time, and the question will become not whether geomagnetic storms influence earthquakes, but how we prepare for it, how we predict it, how we mitigate the risk. There is resistance to this idea in the geophysical community, and that resistance is understandable. Earthquake. Prediction has a long and troubled history of failed attempts and pseudoscientific claims. The field has been burned too many times by correlations that did not hold up, by mechanisms that sounded plausible but turned out to be wrong. The default position is skepticism, and that is healthy. But skepticism should not become dogmatism. When multiple independent studies using different methods arrive at the same conclusion, when real-world earthquake clusters align with the predicted timing, when the proposed mechanisms are physically reasonable even if not yet proven, then the responsible approach is to take it seriously and investigate further. The energy budget calculations are challenging. The total energy in a geomagnetic storm is enormous, but most of it stays in the magnetosphere. Only a tiny fraction of that energy actually couples into the solid Earth. Is that fraction enough to trigger earthquakes? For a fault that is already at critical stress, already on the verge of failure, the answer might be yes. Earthquakes do not require large external triggers. They just require a nudge, a small perturbation, something to break the static friction that is holding the fault locked. If geomagnetic storms can provide that nudge, even to just a small subset of faults that happen to be critically loaded at the right time, then the statistical correlation makes perfect sense. We are living through a test case right now. The storm is happening. The clock is ticking. 27 days from today brings us to December 9th. If large earthquakes start clustering in the weeks following, particularly in regions that were under the polar cusp during tonight's peak activity, that will be impossible to ignore. And if those earthquakes happen while 3i Atlas is at its closest approach, while Borisov is still in the inner solar system, while the space environment is still disturbed by ongoing solar activity, then the pattern becomes undeniable. The pieces fit together, the mystery deepens, and the question of what we are really dealing with becomes more urgent than ever before.